Hello and welcome to our lesson on characteristics of graphs. So we're going to be looking at some generic graphs today and trying to determine things like over what intervals is the graph increasing, decreasing, constant, positive, negative. We're going to talk about end behaviors, and then we'll sort of culminate with the problem where we could sort of utilize all the notations that we've talked about so far. Okay, so let's start with what does it mean for a graph to be increasing, decreasing, or constant? I think this is a pretty straightforward concept. So for instance, if I was to draw this line, would you say that that line is increasing? Maybe. If I was to draw this line, would you say that this line is increasing? Maybe. Okay, well in fact only one of those lines is increasing. Because by definition, when we're trying to determine if the graph is, or decide where the graph is increasing or decreasing or constant, the way we want to read the graph is from the left end to the right end. Just like we read on a book, we go from left to right. That's what we want to do here. So this first one, if I was following from the left end to the right end, in actuality, we are decreasing. If I go from the right side to the left side here, we are increasing. So this was decreasing, this was increasing because we're reading from left to right. So what does it mean for a graph to be increasing? Well, increasing intervals are going to be parts of the graph that are going up, and again that is from left to right. Decreasing intervals are going to be parts of the graph that are going down, and again that is left to right. And if you're reading from left to right and your graph isn't going up or down, if it is flat, then we say that that would be an interval of the graph that is constant. So constant intervals are parts of the graph that are flat, or horizontal, or have no slope, or aren't increasing or decreasing. And again, I think the concept is pretty straightforward. What can be tricky about it sometimes is how we state the interval. Okay, so when we are trying to tell someone where the graph is increasing or decreasing or constant, what we want to identify is the x value where that interval starts and the x value where that interval stops. So from what x value to what x value is that graph increasing, decreasing, or constant? So like the domain, these intervals are stated using the x values where they begin and end. Okay? So if we were to read this graph from left to right, this first section of the graph we could say is definitely increasing. So this is increasing. And then if we were to keep going here, this next piece of the graph is constant. It is flat. Okay, and then if we were to keep going here, this last part of the graph is definitely decreasing. Okay, again, I think that concept is not so terrible. So we've got an increasing interval, a constant interval, and a decreasing interval. So now, is how do I identify where those intervals are? And what we want to do is use the x values that correspond with where those intervals start and stop. Okay? Now let me get rid of these highlights just so I don't get too messy with highlight. So this first piece that we said was increasing. Let me go back to green here. Is going forever this way and then stopping here. So if I was to highlight the x values where the interval starts and stops, we are looking at this graph going from here and then all the way toward positive or toward negative infinity. So here, which is at 1, and then we've got negative infinity because it's going forever that way. And then constant corresponds with this section of the graph. Okay, it starts here where the other piece left off and then ends here. So we're going to say it's constant over this interval. So this interval from 1 to this would be 4. And then the last piece of the graph is decreasing. And the last piece of the graph corresponds with the interval that starts at 4 and is going to go forever toward positive infinity. Okay, hopefully that's clear enough to see. Okay, so we would say that the graph is increasing from negative infinity to positive 1. Oops, almost wrote an 8. Negative infinity to positive 1. And then we would say that it is constant from 1 to 4. And then we would say that it is decreasing over this last interval, which is from 4 to positive infinity. Now we talked about parentheses and brackets in our last lesson when we were dealing with whether to include or exclude values. And hopefully we remember that these infinities are always going to get parentheses. Now we can't actually be increasing, decreasing, or constant at a point, only over an interval. So we are always going to use parentheses for these intervals. So at 1 itself, that specific point, nothing is happening, but along the interval in between negative infinity and 1, actually that's negative 1, the graph is increasing. So we'll always be using parentheses. Okay, so the same thing here, can't be increasing or decreasing or constant at endpoints, and then the same thing here. So all of these are going to get parentheses. Okay, so now the next problem, same thing, we're just going to be going in reverse. So this next one says to look at the interval from negative infinity to 0 and determine what's happening with the graph. So negative infinity to 0, if I was to highlight, it's going to stop there and it's going to go forever this way. And we can see that that section of the graph is decreasing. So we're going to say that is decreasing. Decreasing. Okay, the next interval it's asking us to look at is from 0 to 3. So from 0 to 3, that interval corresponds with this portion of the graph, and that is definitely increasing. Okay, and then the last interval says to look at is from 3 to infinity. So from 3 to infinity corresponds with this section of the graph, and we can see that that is constant. And constant. Okay, not so terrible, hopefully. And next we're going to be looking at distinguishing between positive or negative intervals. Now this gets confused a lot with increasing and decreasing because they sort of sound the same. But the positive and negative is not really talking about the behavior of the graph. It's not, is it moving up, is it moving down, is it staying flat? It's really just asking about the y values for certain sections of the graph. So positive intervals of the graph are parts of the graph where the y values are positive, or negative intervals are going to be parts of the graph where the y values are negative, which means positive intervals have to be above the x-axis, and negative intervals have to be below the x-axis, because above the x-axis the y values are positive, and below the x-axis the y values are negative. And so what's separating the positive from the negative intervals would be the x-intercepts. The x-intercepts, which are sometimes also referred to as the roots. Okay, and just like with the domain and the increasing, decreasing constant intervals, we want to state these intervals using the x values where they start and stop, or where they begin and end. Okay, so when you're trying to identify where your graph is positive or negative, start by finding the x-intercepts or the roots. So for this graph, we can see that it's crossing, this is our x-axis here, it's crossing the x-axis right here at x equals 4. So everything before that and everything after that is either going to be positive or negative. So before 4, this portion of the graph is below the x-axis, so we're going to say that this portion of the graph is negative. And then this portion of the graph after 4 is above the x-axis, so we're going to say this portion of the graph is positive. Okay, so the x-intercept is separating those two. Now, over what intervals are we going to state these things are happening? So this negative portion of the graph corresponds with this interval of x's. Okay, so we're going to say, nope, let me go back to blue here, that everything from negative infinity up to 4 is going to be negative. So this is going to be negative from negative infinity to 4, and then everything after 4 would be here, from 4 to positive infinity is going to be positive. So this is going to be positive the rest of the way, from 4 to infinity. Okay, so if you're feeling good with this and you want to try the next one out, this might be a good opportunity for you to, sorry, you might need it for a second, to pause the video and give it a shot. If not, we can absolutely work through this next one together as well. So next one, again, I want to look for the x-intercept. This graph is crossing the x-axis here, which is at -8. So everything before or after is going to be above or below. So this section of the graph is above the x-axis. So we're going to say that this section of the graph is positive. And this section of the graph is below the x-axis. So we're going to say this section of the graph is negative. Has nothing to do with whether it's increasing or decreasing. It's just where is it, okay? So this first interval that is positive is happening here, and the next interval that is negative that is happening here. Excuse me. So we're going to say this graph is positive from -infinity up to -8. And we're going to say this graph is negative the rest of the way. Negative the rest of the way, which is from -8 to +infinity. Okay? Alright, moving right along. So not only should we be able to identify where our graphs are increasing, decreasing, constant, positive, or negative, we should also be able to identify and state the end behaviors for our graphs. So the end behaviors are exactly what they're describing. They are the behaviors of the graph at its ends. Specifically, the end behaviors of a function are used to describe where the y values of a function or of a graph are headed as you follow that graph to the left and to the right. So if you go to the left end of the graph and you go to the right end of the graph, where are those y values going as you follow on those ends? Okay, so let's look at this graph. If we were to follow this graph to the right, if we went to the right side of the graph and we were to follow it, let's try to figure out where the y values are headed. So there's the right side of the graph. If I follow this graph to the right and I just keep following that right end, what's happening to the y values? Well, at the same time that this graph is going to the right, the y values are increasing, right? So we would say as this graph is going to the right, the y values are going up. And that's the end behavior. But we have to state this mathematically, okay? So here's how this looks. This is the mathematical notation that says, as we follow the graph to the right, the y values go up. Following the graph to the right, we would say, like this, as x goes to +infinity. Okay, if we were on the x-axis heading toward +infinity, we would be going to the right. So that's how we say follow the graph to the right. So if we're going to the right end of the graph and the graph is going up, the y values are going up, then we state that like this. We would say the y values are headed toward, up forever would be toward +infinity. Okay, so this is the mathematical notation that says as we follow the graph to the right, the y values go up forever toward +infinity. Okay, now let's try that again with the other end. So on the other end, if we go to the left end of the graph, so the left end's over here, if we keep following, what's happening this time is the y values are going down forever toward -infinity. So as we go to the left, this graph, the y values of this graph are headed down toward -infinity. So here's the notation. We would say as x goes to -infinity. So if we're on the x-axis headed toward -infinity, we're going left. So that's how we say follow the graph at its left end. Okay? Now as we follow it at its left end, we want to say the y values are going down. So we're going to say the y values are headed down, and down forever would be toward -infinity. Okay, so the notation is a little tricky, but the concept's not so bad. Alright, so let's try that again with a few more. And luckily we're just going to be filling in the blank here. So first, this says as x goes to infinity. As x goes to infinity, if we're on the x-axis toward infinity, we're headed to the right. So this says follow the right end of the graph, okay, go to the right, and what's happening to the y values? Well, as we go to the right end of the graph here, it's going up, which means our y values are going to be headed toward +infinity. Okay, that is up. And next, right here, when it says as x goes to -infinity, Get rid of this. As x goes to negative infinity. If we're on the x-axis going toward negative infinity, we're going to the left. So it says go to the left. And if we go to the left end of the graph here is headed down. That means our y values are going to be going down forever toward negative infinity. Negative infinity. Okay? How about over here? Okay, same thing. This says go to the right. On the right end, again, this graph is headed down. So down toward negative infinity, which means as we go to the right, our y values go down toward negative infinity. And the same thing's happening on the other end. If we go to the left end of the graph, it's headed down, down toward negative infinity. So both the left and right ends head toward negative infinity. Okay, and then this is the really strange one, and if it doesn't make a lot of sense now, it's okay because we're going to come back to these in another chapter. But let's start with the left end. Okay, as we go to the left end of the graph, the left end is headed up. That's no big deal. We know up means positive infinity. So left end's going to go up toward positive infinity. The other side is the tricky side. Okay? If we go to the right end of the graph, the right end here, what's happening? Well, it's going to continuously be going to the right here, but is it going to go down forever? Okay, the answer to that question is no. So I'm not sure if you've seen this dotted line before in a function. That dotted line is something called an asymptote. Again, we're going to be talking more about these later. But basically, it's a barrier in the graph. It's there to show you that the graph is not going to be below that line. Okay, so the graph is not going to be able to go down forever. It's just going to be getting closer and closer to that line. So what's happening to our y values? Well, this is technically a y value of 1 here. Okay, so here we're at a y value of 2, and then maybe here we're at a y value of 1.5, right? Maybe here we're at 1.25, and maybe a little lower is maybe like 1.125. And what's happening as this graph gets lower and lower is we're getting closer and closer to a y value of positive 1. And it's not going to be able to go past that. It will not be able to go below a y value of 1. Okay, that's what that asymptote or that barrier is saying. So as we go toward the right, our y values are getting closer and closer to positive 1, and they will not go any lower. Okay? So again, that one's kind of tricky, and we'll be talking more about asymptotes later, so don't stress out too much if that's a little confusing at this point. Okay? Alright, so let's get one last question here, where we sort of put together several of the concepts that we've talked about. So we have this graph of f of x that's shown, and we have to determine which of the statements apply. So which of the following are going to be true? And you could see some questions like this appear in your practice or on a quiz. Okay, so the first one says f of negative 7 equals 20. F of negative 7 equals 20 means that we should have a point on our graph at negative 7, 20. So an x value of 7 producing a y value of 20. Do we have that? No, we have the reverse, which is not the same thing, so we're not going to choose this one. That's not true. B says f of x is increasing from negative infinity to infinity. So is this entire graph, increasing? Absolutely. From left to right, it is increasing. So we can circle that one. It's true. Y-intercept at 0, negative 12. Does this graph cross the y-axis at 0, negative 12? Sure does. Okay. Next it says, as x goes to negative infinity, f of x goes to infinity. So that's saying if we follow the graph left, that it's going to go up forever. So if we go to the left end, is that graph going up? No, in fact, it's headed down toward negative infinity. So we are not going to choose this one. It's really headed down toward negative infinity. How about f of x is negative from negative infinity to positive infinity? So f of x being negative all the way through means the entire graph is below the x-axis. Now it's kind of tricky because the entire graph that's pictured is below the x-axis, right? Here's our x-axis here, and here's our graph. Okay, the entire picture is below, but what's going to happen eventually if this graph continues to rise is eventually it will cross over. So We cannot say over its entire domain from negative infinity to infinity. We're not going to say the whole thing is going to be negative, because eventually it will go above the x-axis. Okay, and then the last one says f of 8 equals negative 10. That means we would be looking for a point at 8, negative 10 on our graph. And we can see here that that point does in fact exist on our graph. So we will choose f. So we're going to say this one is not on the graph. And this one is on the graph. Okay, and there you have it. I think a pretty straightforward lesson, but as always, if you need any help, just reach out. Alright, take care.